trying to hack cryptocurrency using ChatGPT in 1 hour. Right now, I'm learning about it. Learning about quantum computers. Right now, I want to create a quantum application using a modern computer to unencrypt SNS or RSA encryption. And basically, RSA encryption is two. Let me go back to up here. Be two big numbers factored into a small number. You'll get the N, but you won't get the two big numbers. If you got the two big numbers, then you can unlock the hack or unlock the inscription. And these are examples. Let's say we pick two small prime numbers just to illustrate. P equals 61, Q equals 53. Multiplying them together, N equals 61 times 53 equals 3,233. The composite number is 2,233. Why is factoring hard? Because they use big numbers instead of small numbers like 15 equals 3 times 5. The prime factors are 15 or 5 and 3 and 5. But what if we had large numbers like 3,233? From my earlier example, factoring 2,233 is not as straightforward as factoring 15 because we don't immediately see the prime factors, 61 and 53. So for a computer to factor something like a big number, 3,233, you will get, they say, how long? It would take, they say millions of years. Oh yeah, because it get bigger than that. It gets like 300 digits long and 600 digits long. And that's where I have to figure out an algorithm to actually bring that to like something we can understand or something the computer can understand easier and get to a solution quicker. So I already copied something. I'm gonna ask it to make me a Python script for it. And basically, this is would be roughly 600 different long. Yeah, just give me a Python script that does this, and it should run it. I guess if it takes millions of years, it won't run completely. But that's where we're gonna find the inscription. Okay. So the first Python script, it looked like it's giving us a divisor to brute force into finding the divisor of the large digit. I don't want to. I'm gonna start with something simpler. Two digit. A two-digit composite number. Oh, it's still writing. Okay, okay. If we can't do that, let's start with a simpler number for now, just to get some code written on the on scripting the inscription. Okay. Be too small. And it shouldn't take a million years to figure this out. The script generates random two-digit composite number. In the case 91, it performs brute force factorization by trying to all possible divisors starting from 2. For 91, the factors are 7 and 13, which are printed as the results. This method works efficiently for small numbers like two-digit composites, but it becomes impractical for larger numbers due to the exponential increase in computational time required to. So I should be able to run it. Okay, let's go. Let's try to run it. New file. Let's say hack1.py. Okay. Python hack1.py. 70 factors of 70 are 2 and 35. So 70 was the composite number. So basically it's just guessing. It's just guessing. Say if I was to use this on an inscription, what if that guess was wrong and wrong and it was two other numbers? Right, the brute force approach to factoring a number, essentially a guess and check method. Let's try different divisors. So basically, we just guessing a number. We're not getting to a number. Descriptions like RSA, the number being factored denoted as n is a product of two large prime numbers. Because prime numbers are harder to guess, they have a few divisors. It becomes computationally infeasible to just guess the correct factors in the large number. How RSA uses this. I'm just briefly going over this stuff. You guys can read it. And you try. Of which are prime numbers. So so it's okay. So it only that could make this final. uh, And I'm not 100% good on math, but I'm learning. Large prime numbers, let's call them P and Q. These two primes are the only factors other than one in itself. Okay, that makes up the composite number. So when trying to factor in, you're especially looking for two numbers that are both prime. Python script that does this with three numbers. And this ChatGPT gonna run out soon because this is about my fifth prompt. All right, and as you can see, it's been like 10 minutes, so it looked like breaking this description will take a little while, especially if you don't know how to do the math in the first place. But let's check it out. Okay, hack 2. And as you can see, my naming convention was really easy from my last video. 2.5. Okay, we got 323, 79. I thought it was supposed to be three digits. No, I wanted to composite number to be three numbers. Okay, forget all of this. Give me a Python script that gives me the scenario from what I showed you earlier, but only shoot. Forget scenario I showed you earlier with the RSA with the RSA Encryption. And I'm only writing this prompt to make sure I'm on task. RSA inscription with the RSA inscription, but do it on a small scale. Don't use very large numbers of numbers. Use okay. Shoot. Let me just send this off. Select two large prime numbers, P and Q. Compute the totient. I don't know what that means. I don't know what that means. Choose an integer description key such as calculate the description key D, which is the modular inverse of E modulo. That's just plain text converted to the integer M computer. Let me just compute it. I'm a little catching up to this speed of this AI and all these math computations. My laptop just phased out. Let's charge it. Let's charge the laptop first. Okay. Would it work? Prime numbers using RA scripts are much larger. Okay. This is why I wanted to take this method and just go over it and just run this script. I'm going to tell you guys in a second what I will do next in breaking this down. Okay. We'll get an explanation. Explain this output to me and explain what happened. Let's go over the output. The script generated two random prime numbers, 197, 277. These two prime numbers are used to calculate the modulus, which is an essential part of the RSA encryption and decryption process. The public key is made up of two values. You guys probably don't want me to read. This is commonly chosen value. The public exponent RSA encryption known for its consistent security properties. Okay, so it's two values of the inscription. The public key is used to encrypt messages. Okay, so that's why I use hundreds of numbers. So the next step I would say is damn, that's a lot of stuff. It then went to using set theory. Okay. String height is converted to UTF-8 integer representing M equals da 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 da. Then using the public key in E, this ciphertext C is computed as C equals in mod C equals 26729 to the 655 37 power and MOD. Where does that come from? I'm not sure. The original message high. Okay. So basically, encrypting and decrypting. But I want to take it a little further, so I'll need another GPT. Go ahead, come over here. Okay. Go to here and see. Oh, what did I have planned for the inscription? Okay. I want to. Okay, that's what I want to do. I want to. I want to gather the two. I want to keep slipping my mind what I want to do. What did I just copy this whole thing? Okay, copy this whole thing. I want to gather the. What did I want to change? Okay, I want to get this output, but after the output, I want it to keep going to add a digit to the number and try to find the oh shit, I'm on the wrong thing. Okay. Okay. I'll put this here. Okay, I want this to run, but also I want after the output is done, I want it to keep going. I want it to add another random number. Nope, not even random. Another number. It should be just an increment, but increment of the next number. So if the number is above to 1, the next computation would be 5543. Then 31. And that next will be 554311 21. Okay. This will be a very detailed script, so take your time. ChatGPT is one of the best workers. Make sure video is still running. Pending. I know this script will not, ChatGPT will not figure this out correctly on the first time. It would take another implementation. But the thing, what I want to do is I want to render every number that can be possibly deciphered, descripted. If you render every number that can possibly be descripted, then every prime number that can possibly be descripted, then you can easily find out how to decrypt the inscription. If it's already there, then the computer can easily build an AI, or an AI can easily figure out how to match the pairs and get to the numbers if all the numbers are set. I don't think anyone have a database with all the possible numbers that could be encrypted. Because if you do, then you should be able to build an AI that can decrypt it. But once again, I don't know that it's possible. And that's why I took this from an article of quantum computers doing it. And quantum computers is smart enough to build those numbers and do that. What is this? Okay. Okay. Do you want to continue? Okay. That's a good thing. Okay. And then what I would do when building an application, I would just run the application until it keep running, keep running, keep running. I guess a computer wouldn't take, and if I do it this way, the computer wouldn't take millions of years of doing it because I can do it on other computers. I can keep running the scripts on as many computers as I want. If I use a million computers, it would take 1 second instead of one computer taking a million years. Okay. Hack 2 5. Oh, I have a valid. They say enter a starting number to a script. Oh, descripting file. Did I change it already? Hold on. Did I copy this, the ChatGPT script, or did I just run the last script? I did. Enter a string number to encrypt. Description file. What is it doing? Huh? Okay, it's not. Why is it? I don't understand that. Did it not? Why did it give me a message the first time? It's keep. It was giving me random messages. That's wild. Hmm. Explain this output. why it's not why it don't keep running. You explain this output and why doesn't it keep running? Failure is likely due to how the description process handling the input data files and format. Let's walk through the possible causes in detail. Length versus RSA key size. Once again, only script must be smaller than the modulus. In this case, or bytes, it might exceed the size and can handle during inscription. No, I'm saying no. The application is supposed to figure out the the combination numbers to find the next number. Like so, but the incremental must make check if it's a prime number, right? Because we only can use prime, right? For you want the encrypted numbers to be generated, and each new number must pass a chime check. Essentially, the program needs to continually append digits 4441, 4442. It should only proceed if the result number is prime. This task involves two key improvement: generate new number incrementally, verify that each increment number is prime number before proceeding. Below is revised version of your script with logic that increment the number digit by digit, check if a new number is prime before proceeding inscription, and description keep running until you decide to exit. Okay, let's see, will this work? I'm lucky I read it because it's still processing. Man, this 20 minutes in, I think, or what, 30 minutes that we started. Let's see, we still running? Yep, been running 30 minutes now. Okay, let's see, will this work? Man, GPT is really putting in work today. So, let's see. This should fix our problem of it not running. Like a heck to. Get the okay. End script. Is that too big of a number? Hmm. Hmm. Two. Seven. 4. That'll be the key size. So that runs and that don't. Hmm. So that runs. Oh yeah, I forgot we were supposed to start from a small number. What did I just do? I doubt that's gonna run. Extra. GPT. This is the reason why it's taking a lot while to run. So you can tell me, explain more. So run or incremental number generation. Let's go over the potential bottlenecks and optimizations you can apply. Prime checking becomes slower. Um, without optimization. Okay, so it's without optimization. What explain why? Prime check. Well, I guess basically trying to make the inscription. I guess use more efficient prime checking algorithm. Okay. Could you give me the full script with the more efficient model version? What? Check my phone. 2 seconds. Be right back with you guys. Okay, let's see. Could we hack Bitcoin yet with this SNS RSA encryption application I'm building? We should be able to hack Bitcoin within an hour using ChatGPT. Okay, this is a lot of stuff that I don't want to go over. This is the new prime checking way, the optimization. Let me see. Oh, optimization is just make sure that it had prime numbers instead of searching with factored numbers, I will say. And I'm not 100% sure. Because once again, I am a programmer and not a mathematic. I don't even think I knew how to play, uh, what's that prime game? Prime? Numbers Prime? Prime? That prime game back in school that they used to play on the computer? Numbers Munchers. This is Numbers Munchers. I should have learned how to play Numbers Munchers when I was younger, but never did. It says too large. Keep saying it's too large. Okay, here we go. So I have to start from. Okay, I see what it's doing now. It's taking the primes for those small numbers. Hmm. Oh, then it gets too large because it got the 419. This is too large for this key size. Okay, it was working until we got to here. Okay, let me go back here. I'll go back to my new chat GPT. It was working good until it got to a point. Just explain why it did not work after that point. And the description only works for messages smaller than the modulus. Let's walk through the problem and solution. Your RSA public key consists of no. Okay. Modulus 32,437, 65,000. When you try to script the message, the number value of 49 is converted from string to integer is 419, which is smaller than in script is fine. But as you increment further, okay, the number value, so it did in script 419. Or was this it? Current, what did the last time it said? Current prime number is this descriptive. And it should say boom, boom. Okay. RSA encryption works by performing text equals plain text mod n consists of n modulus e public exponent. When you try to script a message 419, the number value of 419 converted to a string to integer. As you increment further, grows potential seeing the number. So if I can do all the smaller digits, I can get the digits for that. Let's see. Key size. Oh, it can increment the keys. The message generate larger primes and the larger n. You can modify the prime generation range to something like a number between start and end. Okay, so the primes can get bigger. Those larger RSA keys capable of scripting larger numbers. Okay, that's what's going on. Scripting. And we are encrypting the numbers. And we've seen every possible encrypted number. We want to create every possible encrypted number. And once we do that, we'll be able to build an AI system to decrypt the numbers. Then we can uh, safely hack Bitcoin within an hour. We got 30 more minutes. Okay, you should just give me the full script. Please. Let me do 2 videos so I don't mess up one. Oh, this computer pretty strong. I have a lot of memory, so it should save. I can do it all in one. If it deletes, it deletes. Don't. Okay. Let this run. As you can see, ChatGPT is a very powerful coder. It has its own boundaries. And that's the thing about developing AI. Quantum computers are very smart. I think AI is efficient enough to reach some computations if you know how to design it the correct way. And the way I'm developing this application, and within 1 hour, I think is the correct way. But of course, with this will not work. Data set will take probably years to build out. And who's to say that the data set is fully complete? So it'll take a long time. But for this video, we're going to say that we're doing it. Okay, let's run the script. That's 146 lines long. Let's see what we get. Okay, say 4 again. Yes. Yes. Okay, now I see what's going on. As the number gets bigger, it needs more. Why does it keep doing? Okay. Hmm. Just keep running Y. Oh, not that many times. I want those. Okay, so we have prime numbers. Let me suggest to ChatGPT what I want to do. See what it thinks. save. Okay, that's what I want to do. Before I ask them anything about it, I want the outputs. I want this to run automatically after the first input and do 10 at a time instead of me having to keep pushing Y and do, say, 50 at a time. Or just did about 50. Let's say 50 or 100 at a time. So then we have to push Y to continue and also export all the files to all the output, all the prime numbers and the other number. I'll put the prime number, the output, the numbers to a .csv file. Make sure the numbers are with the other numbers. So we should have a file with a head 2 or 3, I think, headers. Okay, now this should be the final script on ChatGPT because I think it's going to run out, so we might have to go to Google and Claude after this script, and it should take about a minute to run. Yep, running about 4 minutes of ChatGPT. ChatGPT speaking. Let's see, could we hack Bitcoin with this application? Yeah. Key. Starting number is script. Okay. Now, right after this, it should run right out. Where did the 100 go to? I want to know where the 100, so I can try to change that number if I need to, in case I only can do 50 at a time. I should say it somewhere. Right to CSV, automated integrations. Where? Oh, here we go. 100, ranging within 100. Okay. Go back here. Let me go to another file. At 3. Once again, naming convention. Perfect. Okay. Boom. 100. This file is 161 lines. And I do not have another ChatGPT, but I have another Claude. I have 2 Claudes if I need to use it. If I can do this within an hour. Enter screen number to the script. Say 4 again. Oh my goodness. No, I wanted this to stop. I don't want it to stop. Stop. I want it to X, Y after the 100. Auto. And do another 100. And what did I just see that I need? Oh, the export. Super lit. Okay, we done it. We just got that computation on one computer. Up to 4,101 from 4. it look like it's just incrementing. Let me run a different one and run a different output file, or just change this output file. X. This is when naming conventions become worse because I'm not caring. Hack, and I'll say 1. I don't even think 1 could go. So we got 1, 4. I should just name it like that. Name 4, 1. Okay, we got hack 3. And go to. I forget what I just did that fast. Oh, nope. Oh, yeah, down here. Terminal. 2. Script. And we got 2. Okay. As you can see, I would just keep going down the rows and numbers and see what I can do with that. Maybe I'll start at a different number. Say hack 3. Let's say 23. Okay, so output for that. See how the numbers will change up. So I can just do basically come from every number and keep automating the system until it gathers all the numbers, what I explained earlier. Alright, this should be it right here. See? And this should take me more in depth into the numbers. Instead of just stopping at 100 alterations, I can stop after maybe 1,000. If it keeps going, maybe I'm gonna have to up the numbers also. Wow, this CSV be pretty super. Oh, 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 oh. Alright, let's see now. It's got a 3,000. This is 3,000 numbers. But if I were to run that for a whole day, imagine how many numbers would it be, and how close we'll be able to get to unscripting it with the AI. But since we don't got time for that, now I want to develop an AI that can figure this out better. So I want to go here. And I want to go to Claude. Okay. AI that could manage these numbers. Let's say manage now, but I'll have to. Oh yeah, the numbers are not in the same. So I had to tokenize these numbers. Plus, I would have to tokenize it to the largest number, I guess. And plus the matrices of the number is off, so I will have to token. I will need. So first, I will need a tokenizing script that tokenizes these numbers. I think we have to tokenize the all three, all three, all three sections numbers. I think it's only 3, right? Yep, all 3 sections. Do whatever go up to the highest. I want to tokenize it differently. Also, I want to use. Usually, I use 0 to tokenize, but I don't want to do that here because it looks like 0 will be used. And yes, so I want to tokenize it with to use man. values. Okay, that should run. See.